Now, this is one question from the chapter Maxima Minima. The question says we have to find the shortest distance of this point C0 from the parabola, which is y is equal to x square, where the interval of C is mentioned here. So if I say this is a parabola, let's say any parabola, let's say this be a point P and whose coordinate I took as 0, comma C. And the equation of parabola is given as y is equal to x square. I took another point, say Q here, and I took this coordinate as h, comma k. This is the coordinate of this. Now further we can see that this point will satisfy this equation. So we can therefore say that k square is going to be equal to be k square, k is y, sorry. So it's k is y here. So k is equal to h square. Now let's find out the distance here that using distance formula. And I'm going to consider this distance, say PQ. I can use say Z. Let Z be the distance. So using the distance formula, I can say Z is equal to whole under root x2 minus x1 whole square. That is h minus 0 whole square. That is will be what? H minus 0 whole square is h square only. This is h. And plus k minus c whole square. Now, before we find the derivative, let's say we can do some substitution. I can see I can replace this h square here from here. Right? So this h square can be replaced with k. So this is k plus k minus c whole square. Now apply derivative, differentiating both sides with respect to, I'm taking k as a variable here. So considering this to be x, root x derivative is 1 by 2 root x. So 1 by 2 times k plus k minus c whole square. And applying chain rule, derivative of this is 1. Let's say I took this 1. Plus derivative of this will be 2 times k minus c, applying chain rule. Now next, we will not find double derivative. We are going single derivative test here, first derivative test. So for maxima, minima, this has to be equated with 0. So clearly on equating with 0, denominator cannot be 0. So we can conclude that 1 plus this is going to be 0. Opening the bracket, I'm getting 2c equal to 0. So I can isolate k here. 2c will be positive on the other side and minus 1 divided by 2. So we got this as the critical point. Now we need to show that for a value which is more than this, I need to keep this for later to be used. Now we are going to apply first derivative test and we'll show that for k being less than 2c minus 1 by 2, we'll simply say that dz by dk is less than 0. And for k being greater than 2c minus 1 by 2, we'll say that dz by dk is greater than 0. All we have been to say that this is the critical point. And as we find the sign of f dash x, or say the derivative sign of derivative before this point, let's say this is the point, we find that it is coming negative, and after this point or a point greater than this, we are finding positive. So clearly this will be called as the point of minima that we need to mention here. Therefore, we should say that 2c minus k is equal to 2c minus 1 by 2 is the point of minima. So once you have written, now we have to find the minimum distance, and then I'm using, say, this one to find the minimum distance. The calculation involved clearly is here. Z is equal to whole under root. K is what? 2c minus 1 by 2 plus k again is replaced by 2c minus 1 by 2 minus c the whole square. Now this is z is equal to 2c minus 1 by 2. On simplifying, this will become 2c, which will get cancelled with this 2c, so it's minus 1 by 2 whole square, which is 1 by 4. Now if I take LCM, so z is going to be whole under root. The denominator will be 4. And this will give you dividing, multiplying by 2. So it's 4c minus 2 and then plus 1, right? So therefore, we have one last step to do, that this z is going to be whole under root 4c minus 2 plus 1 is minus 1 by 4. So we'll say that this is the minimum distance.